I'm Seth with Land to House. Thank you so much for watching the Micro Hydro series. Our penstock is now installed, and I have it down here at the very end of our run. In this video, I'm going to be putting the pressure gauge and surge tank and also the valves here at the end. And then we will take a trip up the penstock, turn the water on, look for leaks, and see what the pressure is here at the bottom. I've come up with this design to put here at the bottom. Let's head to the shop and I'll show you how I made this. This might look like a jumbled mess, but it's about to make sense here in a bit. So basically, I'm going to have this 2-inch valve down at the bottom that will turn off and on the water. I've got a pressure gauge, and I'm going to be installing a standpipe to hopefully prevent any water hammer from affecting the pipes. So let's get this installed real quick. I'll walk you through the pieces as I go. So let's start off with this piece here. This is going to attach to the turbine. It's threaded coupling on one end, and it's just got socket on the other. And so I've already cut some short 3-inch pieces of PVC here. It's all 2-inch components along the turbine. So I'm just going to go ahead and get some of these glued up here, and then I'll walk you through kind of the final setup. Okay. And I've got a union so I can detach the turbine from the rest of the penstock. And so let's go ahead and get that on there. Very cool. Okay, and then I need another piece of 2-inch PVC there. Next is one of these adapters, and that's going to allow me to install my huge ball valve here. So far it's looking pretty good. Now I've got some of this Teflon tape. Gonna wrap this several times. And let's install this, I guess facing, well, yeah, if it goes this way it may hit that. So let's install it where it's facing the union here. Alright, I'll tighten that down in just a moment. We've got another one of those on the other side. But let's go ahead and get everything installed this way first. So I've got another piece of this 2-inch. And that's going to go into this 2-inch T. Like that. And now up from the T is going to be this bushing that goes from 2-inch down to 3/4. And that's where I'm going to have another shutoff valve that goes up to the pressure gauge. So let's go ahead and get that glued in. Okay, very nice. Now we need to connect this T to this one, and this T is where the pressure tank is going to go. Move on to the next T. Keep those straight up and down. Should be pretty good. Install this bushing for the pressure tank. Something like that. And now I need one last piece of PVC that's going to go to my coupling here. So I'm going to install this on the other end over here. And I think I'm actually going to cut a bigger piece so that I have more room to work with. I decided to use a 15-inch piece, and that should give me plenty of room to work with even if I mess something else up in the future. So let's go ahead and get that piece installed. Okay, now I've gone ahead and put some Teflon tape on some of these pipe raisers. Let's go ahead and get those started in here. So what I'm going to do is have a pipe raiser there that comes up to a 3/4 inch T. And that T is going to allow me to install one of these cutoff valves, or these ball valves, so I could drain this tank or drain the system if I need to. I'm sure things will change as I go along, but I just figure this might be a fun way to drain this. And I may actually even add another valve underneath this T. I've got one. That would allow me to drain the T and also not have water coming back up from the penstock. So let me go get that real quick, and we'll install one down below here like this. The idea behind this pressure tank is that whenever a valve is closed too quickly, it will produce a water hammer effect. And so by having this go up here, it will hopefully prevent that from happening. Okay, I got those installed, so I'm gonna get this last one right here. I think I'll do the same thing where I point it down like the other one. Okay, let's make sure that's gonna open and close just fine. Yeah, seems to. And now I've got this bushing here that can be used. It goes from 3/4 to 1/4, and that's where the instrument's going to be attached. I've already put some Teflon tape on it, so hopefully that will keep it good. Okay, and the last thing is this other pipe raiser here, which will then go to the pressure tank. So water will come down through our poly pipe into this PVC. We'll have the pressure tank, so this valve will be closed most of the time. This one will be open, so we have that little air pocket in there. Then we have our pressure gauge, so I'll probably be keeping this closed most of the time, and this will be able to read that pressure whenever we need it to. It'll continue on down here through this valve, and we'll have a union to remove the turbine if we need to, and then we'll have our threads over here, which will then go to the turbine, which is right here. So that's what we're going to be installing out here in the woods. We'll be attaching this 2-inch poly pipe to this 2-inch PVC, and then we'll have this valve open most of the time. This one will be closed, and hopefully this tank here will allow some surge to be absorbed if I ever close this valve too quickly. We'll also keep this closed most of the time. Only when we need to find a pressure, we'll open that up, just so we don't have any water hammer effect that may cause issues there. So let's go ahead and get this piece installed on our poly pipe. To get started here, I'm going to go ahead and put these hose clamps here on the pipe, and then I'm going to be using the same adapter, or this coupling here. It has the rubber gasket inside, and hopefully it will do what we need here. If not, I'll have to find another way to keep all this together. You know, I think I'm going to put it on the PVC first, because it is a bit more difficult to hammer it on there. So this is basically the same step that I did in the previous penstock video. I'm going to tighten this down to make sure it stays nice and secure. Now, just like before, I'm just going to put a couple of these little unistrut here and use those hose clamp to hopefully make sure that nothing pulls loose, because there should be hopefully around 60 psi down here at the bottom, and so I just want to make sure that this doesn't have any issues with pulling loose. I'm also kind of afraid that we're going to have leaks because of these hose clamps, so we'll have to find out. Now, I also want to make sure that I keep the whole system locked down. So I've cut a couple of little boards here that I'm going to use some plumber's tape and a couple of small screws just to make sure that this doesn't fall over. Break off a little of this metal plumber's tape. I find you can just twist this around for a minute and it will break off. Possibly not as quick as using a tool. There we go. Yeah, I actually want my turbine to be over here a little bit, so I'm gonna pick this up and see if I can't rearrange it over here. So this means our turbine housing will be right here, and I can still get by it over on this side whenever I'm walking around. And there we go, that is installed nicely. I'm gonna go ahead and close this off, and I think I'm gonna go ahead and make sure this is off, and we will keep this closed for the dramatic reveal if all of this is working correctly. And we may have to come down here and open this up to allow the air out. Let's head up the mountain, turn the water on, and see what kind of pressure we're working with, and hopefully not find a single leak. So I kind of anticipate that I have over tightened a few of my bars, and it's caused a leak right here where these have pressed in and crimped this. But we'll go up the mountain and we will check each one by one and see what we get. I've made it up here to the top. Our intake box is still doing quite well. All 3 strings are coming down the hill and feeding our 55-gallon barrel. So we should still be seeing somewhere around the 40 to 41 gallons a minute coming in here. As you can see, our outflow over there. So let's go ahead and cap off this drain on the bottom, and we will see about opening this up. Looks like our flow rate is down a bit today. Let me bring up the calculator and see what we're flowing at. So it filled up 55 gallons in 2 minutes. So that would be, let's see, 55 times 60 is 3,300 divided by 120, 27.5 gallons per minute. I'll have to see why. We have plenty of water. Maybe we have some debris trapped in there. Got some air in this line for some reason. Anyway, I'll see what's going on with that. I wonder if we have a slight upward position right here that needs to be corrected. We'll probably move this stick and some stuff and get it worked on. It's not a full tube of water going in there. I pushed the piping down just a little bit, and now air bubbles are coming out, so the flow rate is going back up, which is a good thing. So let's go ahead and open this up, fill the pipe, and go check for leaks. You ready? Here we go. Nice. So I don't really see any leaks here. Once this whole thing is full, we may start seeing something if there's going to be a leak. Now let's walk down here and go section by section and see if we can find any kind of leak. But we should probably give it a moment to fill up. I can hear water rushing by at this joint, but I don't think that means there's a leak. It's just probably a little high spot, I suppose. May have to work with that. I was hearing the water flowing down until I got to this point, and I think, see, it's full there, so it's actually, I can hear it moving up the hill as it's filling. So it's empty here, and now it's full. So it's flowing right around here somewhere is where it's going up. So let's kind of run ahead of it a little bit and see if we can catch it again. Hear that? There it goes. It just ran past us. That's so fun. It's actually filling up pretty quick. Here it comes. And there it goes. I don't know if that translates on video at all, but I can hear it zoom past in person. So I've been working on this for a couple of months, so I know for you it's just a series that's back to back and maybe not quite as exciting, but to at least get to this point has been a lot of fun. Okay, let's see if we can hear it coming. Did you hear that? It just went by. Well, if it makes this point right here without a leak, we'll head down to the bottom and turn it on. Nice. That's so cool. By the time we make it down to the bottom, that will be nice and full, overflowing at the top. We'll go turn it on and see what kind of pressure we're getting. So far, I'm really pleased with what I'm seeing on these couplings. They're all rated at 80 psi, and we should be pushing somewhere around 60 to 64 at the bottom, based on my previous calculations. So hopefully we don't have any kind of leaks. I don't see anything yet, which is a great sign. We may have a leak somewhere down the line because I'm hearing waves of water coming up. But this one, so far, seems good. So there's a dip right here, a slight upward right here, and then back down. So I may have to come back a few times on this stretch and make some adjustments so that there's no upward. And if you come back here and look at it straight on, you can see just a little bit. Comes down, a slight up, and then back down. So apparently anytime there is an upward dip like that one, it will cause problems with airlock or slowing down the system. So, okay, let's go down here to the bridge and see if it's leaking. That little dip there should be pretty easy to fix. No leaks on that connection. Coming down here, seems to be crossing the bridge just fine. I anticipated that it would. The pressure should be gaining pretty strong now off the mountain. I don't see anything obvious. I would imagine there'd be a pretty good stream of water coming out. We may have something here. Let's check it out. Here's our first leak. It's got a tiny little stream right here, you can see. So I don't know if tightening that anymore will work or not. We'll come back here in a second and see if we can't get that to stop. Much bigger leak right here, right at the very bottom. You can see it's got a pretty good stream coming out of it. So we'll see what we can do on that one. I'm noticing that it's come loose about 1/4 inch from my mark, and this one's pretty solid there where it's supposed to be. Maybe tightening it down will help. We'll find out. Okay, let's go ahead and walk down here to the end and see what we look like at our pressure. Whoa, I just heard a big jump. Oh no, the end just busted off. Save the stuff. Yikes. Well, that tells us that that joint right there is not going to be enough to hold that. We were that close to getting a pressure test. So either our coupling here wasn't strong enough, meaning more pressure than 80 psi, or it just wasn't tight enough. I think what I'm going to do is grab one of those rubber connectors and try that out and bypass this one right here. This is going to flow pretty good for a while since it's open at the top. So let's just point it over here for a bit so I can get some work done on this. Let's go ahead and take this off. I got one of the rubber connectors here. So hopefully with the ball valve open down here, the water will just pass straight through. Yeah, nice. We won't be getting too terribly wet here. All right, let's close this up and see what we get here. It's raining enough that I've swapped over to the waterproof GoPro. If you're enjoying the series so far, and I hope you really are, I would greatly appreciate if you would hit the thumbs up button and be sure to subscribe and ring the notification bell. This project is free to you, so if you would just subscribe for me, I would greatly appreciate it. Let's see what the pressure is here at the end of the penstock. I installed this coupling and it has got quite a bulge to it, but it's not leaking. So hopefully that's going to do it for us. Okay, you ready? The big reveal for our pressure down here. Whoop, popped it. Too much for it. Whew, that's crazy. I saw it jump to at least 30 before it popped loose here. I found a couple pieces of rebar and I have kind of sunk those in here around this. I may have to just find some longer unistrut. This is the only pieces I had left. Man, you can see that starting to bulge out there. So it's going to take a little while for that to fill back up. Let's turn this on and see what we get. I can still hear that leak up the way. Let's go fix that real quick or we're never going to build real pressure. I put the same coupling on the one up above. Man, it's a lot of pressure. Let's try this again, see what happens. I'm going to open up super slow. See what we get there. So PSI on that is currently, looks like 20, I think is where it's at. This bulge keeps getting bigger, so hopefully it doesn't bust there. If it does, we'll have to find something else to fix it. Maybe something thicker than that. Let's check our pressure. We're at, let's see, 30, what is that, 25, 30, 35, maybe 37 or so PSI, and it's continuing to climb. So it's got that one leak at least, and there are a few dips that need to be corrected. So I think that we are on our way here. I'll keep watching this for a few minutes and see if it continues to climb. No luck, we blew it again. So I'd opened up this piece right here just a little bit to let a little stream out, and it built up to 49 PSI and then blew the coupling again. So I'm gonna have to find something that's stronger than that to keep it from blowing out. I've tried several things to keep this penstock together. The first thing I tried was these blue connectors from China. They are made for a higher schedule PVC than what I've got. Next, I tried to use these little couplings here, but they didn't stay at all. And then lastly, I have attempted to use these rubber connectors with 4 hose clamps and then 2 more trying to keep it together with these fence posts, but it still continues to pop free. So the next test is to try and use the good old-fashioned Barb fittings, which go on the inside of the pipe, and they do reduce the flow rate some, but if they'll stay, then that's what we're going to go with. So let's try that, and I figure if that doesn't hold, maybe I can use this, that, and that all together. So we'll see. All right, go ahead and remove these hose clamps. I've also got these over here need to be removed. I may keep this on here just to make sure I have more support. Okay. I really was hoping that these were going to work. They seem like they're much beefier than I've used in the past, but it just didn't hold it. All right, so hopefully this pipe will flex enough that I can get these in here. They're pretty cold with all that cold water. Yeah, that may be a problem. May have to get some way to heat this up. I think turning off the water up top is going to be required. Yeah, no way. I decided it wouldn't be possible to get this barb fitting into the black pipe without heating it up. So I went to the hardware store and got this torch. I'm heating up about 4 inches or so I can press that in there. Kind of going on all sides, a little bit on the inside as well. Just makes it way more pliable. Not enough. Yeah, because this stuff is crazy not pliable, if that's a saying. Very stiff without warming it up, I guess you could say. Let me get the inside a little bit. That should do it. Yeah. Get that up to the top there. And then I'm just placing one of these hose clamps around here. Nice and tight. And now I'm just gonna move down here to the other one and heat that up and then try to slide these in together. I'm trying to make sure I have enough slack, and that should do it there. And there we have it, a barb fitting. Instead of going on the outside, it's now inside. I left the fenced post pieces here for hopefully keeping that from coming apart. And we'll turn the water on in just a bit and see how well these hold. I'm back up here at the top where the barrel is. I went ahead and replaced this piece right here with another one of those barbs and got it all fixed back up. I still lack 4 of them along the line. Let's go ahead and close this back up and turn it on and see if we can get a high pressure down at the bottom. Okay, let's head on down and see what we can get. Okay, back down here at the bottom. Let's go ahead and shut this off. Okay, now because there are still 4 of those couplings up top that need to be replaced, we may still bust some of those, but we can at least get a pressure here that up till that point before one of those pops. You can see I also replaced this piece that was down here, so definitely should keep us going. So as you can see, the pressure is back up to 50, and there are at least 4 leaks happening that I know of. So I think we'll be able to get up even more. The ideal is 64 psi, so we'll fix those last couplings and take another reading. There were still 4 barb connectors I had not installed yet, and I was testing the Micro Hydro, and the pressure dropped. There's the problem right there. We've got a geyser. It's been flowing like that for a while too. So yeah, the pipe just came loose. It's a lot of water. So let's go up here and turn off the water, and then we'll replace all of these non-barb fittings. I fixed all 4 of the leaks that I had here on the penstock, and now it is in full operation, holding with a static PSI of 65, which is really awesome. Very excited to have this much power potential in this pipe. Thank you so much for watching this video of the Micro Hydro series. If you've enjoyed it, hit the thumbs up button. Remember to subscribe and ring that notification bell. There are a lot more videos in this series coming up. Thanks for watching, and I will see you in the next video. Bye.